Let's look at some of the additional services that we offer. So when it comes to DHCP DNS, they do exactly the same thing everywhere. So they do the same thing here also. So we use DHCP to allocate IP addresses to clients on a network. So if you want that, NSX can do that for you. And NSX can act as a DHCP server. Or if you say that, hey, we have a DHCP server outside, we don't want NSX to do any IP assignments. We just want NSX to just act as a relay in between. So we can tell NSX, fine, if you hear a DHCP broadcast, you just relay that message to this external DHCP server actually. So both ways you can set it up. The only difference is if you want to have DHCP within NSX Edge nodes can provide that functionality. Or if you just want to have a standardized, I can say, IP management solution. Let's say you don't want to have 10 different DHCP in your environments. You can say the NSX can be acting as a relay in that case actually. Now, there are three types of configurations that are DHCP related in NSX-T. What you see, first one, this is what we call it as a DHCP local server actually. This is like saying that here you have a T1 gateway. Assume this is T1. And there are 3 segments connected to that. So assume this is my segment 1 or something. And only for this network, I want DHCP. Only for that segment actually. So then you can configure a DHCP local server. So this will serve only a specific segment. So anybody connected to this segment, they can basically broadcast for a DHCP IP and they will get one. Whereas anybody connected to other segments, they won't. Or you can have a gateway DHCP, which is like saying we enable a DHCP here at the gateway level. And then all connected segments, you can configure your DHCP server scope, range, scope options and all that. And anybody connected to any of these segments can leverage DHCP functionality then, because it's now configured at the gateway level. Or the relay is simply like saying that, hey, I have a DHCP outside, so I don't want NSX to do any DHCP assignments. Instead, we just tell NSX that, okay, if any one of these machines do a DHCP broadcast, you just send that message to this DHCP server outside actually. So that way, you can have a relay configuration done in NSX-T for DHCP.
Even for DHCP, we need to allow rules by default here, or if we configure DHCP server on the NSX, it will allow by default, or we have to configure DFW rules.
I think as part of the default policy, it's already there. I believe. 1 second.
No, it is there, but normally as like hardening or something, if we are removing it.
If you have removed it, then you have to configure it yourself.
Okay.
If you have removed those default rules.
By defaultly that ICMP and this will be by defaultly the rules will be there and be allowed. So I'm just asking whether it's a required one, right?
So, but if
we have some options in V, right? We can include some of the servers. So similarly, we have it here also, right? Or?
Yeah. You have it, the same exclusion list. Actually, you have it here. It's just that the UI, you have to switch to the manager view. You will see the exclusion list option there actually.
And if I exclude that by NSX manager, like DHCPs in that case, right? Like if I need to exclude, like for example, the DHCP server I want to exclude. In that case, how it works? Like even for all the DHCP flow, it will be allowed, or only on the destination end, any two destination it will be allowed.
See, excluding your DHCP in the NSX distributed firewall exclusion list will only come into picture if you're running a virtual DHCP server as a VM.
Yeah, because normally, in some maximum scenarios, they'll be hosting on top of NSX only, they'll host the domain controllers, everything. So even domain controllers, they will serving as a DHCP DNS if it is there.
So basically, see, if you add anybody to an exclusion list, technically there is no DFW for him at all.
No, not for him. If, for example, for other server trying to take that service, even for them, him it will be applicable, or as the destination is part of the exclusion, even for him it is applicable, or for him we have to add a rule.
For the other person, you have to add a rule for the other machine.
Oh, okay.
Yeah.
I was thinking anything.
So the exclusion is only applicable for the VM that you have added.
Okay. Oh no, I was thinking even that is part of exclusion. Okay, if anything is pointing to destination that is part of exclusion, so by default it will be allowed. I was thinking.
No. So you have to add rules for other destinations.
Okay. Thanks.
All right. So when it comes to local server, that's what you're seeing here. So assume that we have as you can see here, there's a T1 gateway. There's a segment here to which this VM is connected. And if I want DHCP functionality on this specific segment, that's when we will configure a DHCP local segment, actually, local server. You can do this on both T1, T0 gateways anywhere, actually. So whether that segment is on a T1 or a T0, you can configure this irrespective of the gateway type. If you say relay, now in relay there are two possibilities. If you say I have a virtual machine running as a DHCP within the virtualization infrastructure. Now this could be maybe a VM running on a vSphere, which could be part of a NSX overlay, or it could be a VLAN port group that it is connected to. So in such a case, we will configure a relay on our gateway saying that any DHCP request coming simply needs to be relayed to this guy. Now, since this DHCP is running within the NSX infrastructure, T0 is not going to route the traffic anywhere outside, actually, because your DHCP is running within NSX, actually. Whereas if you're running a DHCP outside of NSX, maybe like a physical, or it could be virtual also, actually. But this is connected to a VLAN segment. Technically, this is connected to a VLAN network. So that's the time. T1 will basically forward the DHCP relay request to T0, and T0 is going to route it outside, actually, so that it can reach your external DHCP server out of NSX. So it all depends upon what's the placement of your DHCP. Is it within NSX or is it outside of NSX? Whereas a gateway DHCP is like saying that we'll enable a DHCP on our gateway, which in this case on a T0, and all connected segments to that gateway can now leverage DHCP functionality. But you have to configure the DHCP range, basically the scope or scope options per segment, actually. This is not done on the gateway side, actually. Here we just enable DHCP server, but then the scope specifics, all that is done at per segment level, actually. So this is just a configuration workflow as to how do you set up DHCP in NSX-T. Just like everything else, there's a profile for this also. You have to create a DHCP profile. And then you have to associate that profile either to a segment. In case if you're trying to create a DHCP local server, then you will map that profile to a specific segment. If you want to create a DHCP or a gateway DHCP, then you associate that profile either to a T1 or a T0 gateway, actually. And then you have to configure DHCP specifics like the DHCP scope options, all that logic. And then eventually connect a VM and do a DHCP broadcast. The VM should get an IP address. So that is what they're trying to show you here. So this is what you see on the top. This is a relay profile we are creating. This is the profile type. And this is the IP of your actual DHCP server, which could be sitting outside of NSX or it could be sitting within NSX. So we are simply saying that, hey, when a DHCP request comes, send it to this guy. Or you can create a DHCP server profile. where now you have to define a DHCP server IP. Now this DHCP server will be hosted within NSX-T. And you have to associate a edge cluster also when you're doing this. Why? Because that edge cluster will host this DHCP server. So this is relevant if you are basically planning to do a gateway DHCP server or a DHCP local server, then you have to set up a server profile actually. So once you have this profile created, who do you map it to? If your intention is to create a DHCP local server, then you technically go to a segment, like we are showing you this app segment here, and we associate the DHCP profile there. So it could be a relay profile or it could be a server profile, depending upon what you want actually. So here in this example shown, we are saying that we are associating a DHCP relay profile. So tomorrow, any VM which connects to this app segment, if that VM is configured to get a DHCP IP, if that whenever the DHCP broadcast happens, that will be forwarded to our DHCP server, which is fundamentally this guy right here, as per the profile. And this server is sitting outside of NSX. If you want to create a DHCP local server, or a gateway DHCP in this case. So if you notice, this is one of our T1 gateways. And we're associating a DHCP server profile configuration here. And this is gateway DHCP. That means now these segments that you see here, which are connected to this gateway, both those segments are now eligible to use DHCP services actually. Both of them. So how do you set DHCP server specifics? So you have to do this at a segment level. So as you can see here, we are going into the app segment. And here we are defining this as, let's say in this case, this is a local DHCP server that they're setting. And then you define your DHCP scope, other options like scope options, you can do that here actually. And whether you want to give the DNS information, all that, you can customize all that logic. So this is supposed to be done at a segment level. So that's what you have in DHCP, simply put. Coming to DNS, DNS is basically, again, it's a DNS relay service only that we are setting up in NSX-T. Now it has its own benefits, because with DNS relay kind of a logic, you can point your virtual machines connected to NSX segments to a DNS service IP which is hosted by NSX. You don't have to expose your real DNS server for that. So this, in a way, gives you a little bit of DNS security, you can say, because I don't have to expose my DNS server, a real DNS server, to my clients. This also gives you a little bit of performance benefit, because your clients will be making DNS queries to a DNS service hosted by NSX. So the load falling on your real DNS can be reduced, because in this process of DNS forwarding, NSX also does DNS query caching actually. So any subsequent query which is already in DNS cache can be answered by NSX DNS service itself. So in a way, we are kind of reducing the burden also on your real DNS box with this actually. So when we say DNS forwarder set up in NSX, what this basically does, it takes the DNS query from the client, and if it does not have that query resolution within the cache, it's going to forward that query to your DNS box. And when your DNS box responds back, it's going to cache that DNS response, so that if another client makes a similar query, we can basically resolve that from the NSX DNS cache itself. Now, obviously the DNS cache is valid for a certain amount of time, so you can customize that ETL beyond which, again, if the cache has expired, the request will be forwarded to your external DNS box. So what is the configuration workflow? Like, how do you set this up? You have to first create a DNS zone in NSX-T, and then you have to configure a forwarder service. Basically, you have to configure a DNS service IP and then the forwarding IP. And then you have to establish connectivity with your DNS server, your external DNS server. And if you're either manually configuring the DNS in your virtual machines, or if you are leveraging DHCP, and in DHCP options, if you are allocating DNS service IP, you can basically make clients point towards NSX DNS with these methods actually. So this is kind of step one. We are creating a DNS zone. So this is the default zone. Now in the default zone, you're actually mapping your real DNS actually. This is the real DNS that you have sitting outside. You can also create specific FQDN based zones actually. So here I'm creating one of those sample zones and I'm saying if the domain suffix is lab.com, then forward the DNS query to this guy. Now this is a DNS service IP hosted by NSX. So like this, you can have multiple, you can say FQDN based zones. I think the limit is somewhere around 5, I believe, I think.
Hello.
So any DNS queries which are matching this FQDN will be sent to this specific DNS. Anything which is not matching any of these, the default, which is not matching this FQDN zone will be sent to the default zone, which is fundamentally your external DNS actually. Now in terms of configuring, so you have to create, once you have configured zones, you have to create a DNS service. So if you notice here, we are creating a DNS service. We're associating that to one of our gateways. Now this could be a T1 or a T0. And then this is the DNS IP that NSX is hosting actually. That means your client should be using this as a DNS IP. And then this DNS IP is going to forward the queries to this DNS zone in which we have mapped our real DNS outside. And since we also configured some FQDN based zones, you can also map a total of up to 5 of them here actually. So tomorrow from the clients, if there is a query, if a DNS query comes for a specific FQDN based zone, it will be sent to the DNS server listed in that zone actually. But if a client says, hey, I want to reach maybe some ESPN.com or something, then which is not matching this FQDN zone, it's going to forward that to this default zone, basically your external DNS server actually. Now, in terms of how will the NSX DNS service IP talk to your external DNS actually. There are 2 ways to achieve this connectivity. One is this DNS service IP that you're configuring, you can advertise that from your NSX gateway upstream so that your external network can actually access that IP. And as long as you have routing configured between this and your DNS server, it should be fine actually. So you just have to do a advertisement from the NSX gateway about that DNS service IP actually. That is option 1. Or the other option is you can do a source NAT actually, where you can say that this DNS service IP, whenever this is talking outside, translate that to some IP as per your external subnet. Because generally towards DNS, again, you have, you can say subnets restricted actually. Because if you open all subnets towards your DNS, that also creates a problem of security. So generally you will have some restricted subnets only allowed to make DNS queries to your DNS box. So maybe NAT do a source net for the NSX DNS forwarder IP to have its traffic source netted to one of those subnets which are allowed to talk to your DNS. So this is the other option that you can make use of to have that forwarder connectivity actually. All right, so that's what you have in terms of these services. Any questions, guys, on this till now? Okay. So